Hey everyone, thanks for joining us. Welcome to the Builder Nation podcast, where we speak with engineering and operations professionals about anything hardware, right? Innovation, creating new things. I'm Marcus, and I'll be speaking with Jonathan Nutzati today. I'm engineer, innovator, and future Mars colonist. We got to dive into that a little bit further. But Jonathan, hey, great to have you on. Please introduce yourself, share a little bit about where you're coming from, what you're working on today.
So I'm an aerospace engineer. I'm really interested in things to do with energy and propulsion. I love designing vehicles, so vehicle architecture and problem solving. I like to be sort of a Sherlock Holmes of engineering. Like, oh, why is this machine making this noise? Well, let's figure it out. Let's pull up the drawings. Let's watch it operating. Let's collect some data, and I'll write you a nice PowerPoint for why I think it's making the noise.
I love that. I'm a big Sherlock Holmes guy. Watson too. Got to give the shout out. Awesome. Well, hey, everyone, in today's episode, we're going to be talking about entrepreneurship in hardware. Really grateful to have Jonathan on. For his background, right? Coming from founding a company to now working at ZeroAvia. It'd be great, Jonathan, if you could share maybe where you started, right? What got you interested in aerospace engineering and what you're working on today. Then we can hit on what makes the hardware engineering industry successful. Like how do operations and engineering teams work together? Any future trends that you might be seeing, and really advice for folks listening. They could be engineers, maybe folks still in college, or maybe someone out there is founding a company and could really benefit from your expertise there. So please, Jonathan, why don't you open it up and share with the folks what kind of got you excited about aerospace engineering to begin with? What got you into the industry?
So yeah, we can do all that. Let's start from what got me started. I wanted to be an astronaut originally. I was always interested in space. I wear glasses. I have terrible vision. I'm wearing contact lenses right now, so that's why I'm not wearing them. So I was told I was not going to make it as an Air Force pilot. And that's the main path to being an astronaut, and other reasons. I figured I'd be happy working on rockets and designing things that do go into space. So I went and I studied aerospace engineering at Embry-Riddle. I got myself a solid scholarship, and I figured, all right, I'll go learn aerospace engineering and learn to fly airplanes, and that'll set me on the path, and let's see how it goes. So I did that. At first, I was like, you know what, I'm going to want to be a test pilot. And going through the classes, learning flying, I'm like, well, flying's really hard. Test piloting seems cool, but the odds of death are really high. You know what? Maybe let's stick to the engineering side of it. So I look at the engineering. I'm getting into my more advanced engineering classes at Embry-Riddle, learning about jets and rockets, and I'm like, you know what? This is my passion. I like these really fast spinning machines. So I specialized at that point. That was when I needed to decide to specialize. I specialized in propulsion, and in those days, well, it's probably still that the focus in propulsion was gas turbine engines. So traditional, suck in air, compress it, squirt fuel, explode it, shoot it out the back. that's all it was. And so I took an internship in that at MTU Aero Engines in Germany. I went and I was manufacturing gas turbine engine parts. And I thought it was really fun. You walk through the factory and you see like a disc of Inconel, which is a aerospace material that is capable of withstanding very high temperatures and corrosive environments. And they'd say, all right, this disc here costs as much as a Mercedes E-Class. And this disc costs as much as a Mercedes G-Wagon. And I'm like, wow, these are expensive engines, and it's a funny way to show how much each disc costs. And the disc doesn't even have the blades on it yet. So I come back from my internship back to Embry-Riddle, ready to become a gas turbine engineer. I'm like, wow, I did the internship, love the stuff, let's do it. So designed some more gas turbines in my senior design classes, and I'm ready to go. Then I graduate. Tesla comes along. They came to our school and they're like, hey, we're recruiting people for Tesla. You want to come work in California? And I look at it and I'm like, yeah, that seems really cool. What kind of jobs? Like, well, we need a propulsion guy. A propulsion guy? I'm a propulsion guy. So I went there and I'm like, at that moment it clicked and I switched and I'm like, I'm probably never going back to gas turbines. And then I learned how to do it electric. So I learned about electric motors. I was working on the motor team at Tesla. We were doing parts for the induction AC induction motor. It was gorgeous. It was cool company.
I'm curious, making that transition to Tesla and going electric, what were the key differences there? Maybe how did your role change?
The bigger differences were that the output of the shaft was not turning a compressor. There was nobody calculating blade angles and air pressures. It was sort of torque. We were just focusing on the torque. But I was sort of shaping copper, shaping steel, working with manufacturing, and a lot of CAD. That's been a recurring theme, like lots of CATIA, SolidWorks. There's more similarities than differences. Yeah, I learned a lot about how to take something from the drawing board to making thousands of it in a factory, how to solve problems and actually implement the solution at a factory level. How do you manage a part, an assembly, a system of parts in a corporate design entity environment? I want to say that's so important for hardware. The second you're not focused, you're wasting money, and hardware is expensive. You got to keep your engineering very tight. You need to be going in that direction and nowhere else. Otherwise, you're bleeding money and your startup will fail.
And you mentioned moving in one direction. What would you say are those teams doing differently? Is the collaboration tighter across the board for folks who are, moving in that direction and staying laser focused, or where are the gaps for companies who might be missing in that regard?
Well, if a company is looking for product market fit, right, this is going to be a CEO's job. This is not necessarily on the engineering team. It's like we need to decide where we're going to put our efforts. And entrepreneurship is an experiment. And an experiment, you need to apply the scientific method. You have a hypothesis, you have to test the hypothesis. But a lot of people feel like if they're not doing things, and I'm definitely guilty of this. I'm an engineer. I'm holding a hammer. Everything's a nail. I want to engineer things. I want to design new parts. I want to print new parts. I want to build new parts. But that is not the first step. Should never be the first step. You need to have your hypothesis that this product, this invention, this process is going to solve this problem for these people, and they'll pay this money. Once you've got that figured out, once that is solid in your mind as the CEO of this company, if you're the CEO in this company, then you're like, all right, how are we going to execute this with hardware? How do we spend as little as possible to prove that our technology solves this in this way and gets us this money? Imagine you have a pipette of engineering and you put one drop of engineering and then see how it goes. And then when it goes well, you put another drop of engineering, and like your engineers are going to hate this. They're gonna be like, what are we doing? Our hands are tied. But no, you just another pipette, another drop, and keep turning it up as the success happens. And then when you realize when that formula is happening, laser focus on that. So it's kind of like keep it reined in. Don't hire all the engineers until you need to scale. Have a core team, and being in that core team is tough because you need to have people that know how to do everything. Or an even more important skill, know how to know what you don't know how to find people that know how to do it and ask them the right questions so that you can do it.
I think that's a great segue into how you took your experience at Tesla and went out and started your own company, a mothership, right? So if you don't mind sharing with the folks who are listening, kind of that experience and the learning curve there, your experience starting your own business.
Starting Mothership Aeronautics, I was fascinated by the idea of having an airship that could be self-sustaining, that could generate its own power in flight. The first step was to create a prototype of a solar-powered airship, which I was able to obtain from Boost VC, a $25,000 investment. And we produced the prototype in around 2 months and successfully demonstrated it here in Sunnyvale.
That's exciting. Shout out to the Bay Area. I'm over here in San Jose.
Cool.
Yeah. And thank you again for hopping on so early. Really, really happy that we could dive into this. So you get the thing flying. Talk us through some learning experiences you had in that company. What challenges did you face?
There are a lot of challenges. It's aerospace. It's aviation. There are rules about what can fly. When I first started the company, there was no Part 107. For those of you that don't know, Part 107 is a section of FAA regulation that allows for the use of commercial drones, which before that were simply not allowed for commercial use. You could not fly a drone for money.
Wow.
Part 107 said, well, as long as your drone is under 55 pounds and flies under 400 feet in daylight, and not over people, and you don't operate it out of a moving car and maybe some other details, you can legally fly a drone for pay. And that created a resurgence in the drone industry. So Mothership Aeronautics started like 2 months before 107 kicked in. And after starting Mothership Aeronautics, I went to Interdrone, and I found a bustling community and a lot of excitement and happy people that were like building a whole new world in drones. And I jumped right in. And I was like, all right, well, we got to design a Mothership Aeronautics first product as a drone. It's got to be under 55 pounds and it's got to fly like this under 400 feet. And so I tried to make the product as another drone. That may have been to one extent a mistake. I saw a problem that we were solving, which was pipeline inspections. And looking back now, if I want to look at the most direct path to solve the problem, I was a guy with a hammer, and my hammer was a blimp, and everything looked like a nail. If today, if somebody gave me the problem, you need to inspect 100 miles of pipeline, you want to not endanger people's lives, and you want to save money and not damage the environment with helicopter emissions. What do? I'd say, all right, well, a hybrid airplane, a hybrid VTOL drone airplane costs around the same as a blimp, but it's way easier to use. Blimps are actually really difficult to fly. They're difficult to set up, and you need helium. So after running Mothership Aeronautics for 4 years, I came to the revelation that a Part 107 drone that is a solar-powered blimp is a cool toy, but really that's not where the solar-powered blimp really shines. You got to go big. You're not going to do it with $1.8 million, which is what Mothership Aeronautics raised. And you need to be solving big problems, but it does make sense.
Well, I think the next step to talk about here is your transition into ZeroAvia and how you leverage that knowledge there and what you're working on currently. If you wouldn't mind sharing for the folks listening, what you're working on with the company today.
ZeroAvia is very exciting in what we're doing. I found ZeroAvia through a job posting that basically listed a job that was a hybrid between what I'd been doing at Tesla and what I've been doing at Mothership Aeronautics. It's like hydrogen fuel cell powered electric propulsion systems for airplanes. And when I heard that, I immediately thought, yes, that makes sense. What the company's doing makes sense. And I want to do that.
I'm taking a step back and looking at maybe the future of the industry. Right? Or maybe some advice that you might have to folks in college or looking for that next role. If you wouldn't mind sharing your perspective in that regard.
I'd say get an internship as soon as possible. College does not prepare you for what companies look like, what jobs there are. I realized after working at a company, I'm like, all right, this job, for example, instrumentation guy, like a test engineer, I had a class in college called Structures and Instrumentation. There was just one class, it was like 3 hours a week for 4 months. And Structures and Instrumentation, while it was one class for me, was a whole job for another guy that I ended up working with a guy that does that. And it goes pretty deep, but you just brush over all these things in college, and your professors don't necessarily always tell you like, hey, this is a whole specialization, or here's a field that basically relies on these two classes. Like, for example, test engineer. Test engineer, essentially they're a project manager, they're a scientist, they work on instrumentation, they look at a lot of data. There's a lot of jobs that don't fit into, like, I feel like a college degree prepares you for like a pinnacle job. And I'd say like my college degree specifically prepared me to be a mechanical design engineer for gas turbine engines. You need to know what the options are. If you specialize early, you have a better shot of getting what you want.
I like that. I like that. And maybe you could speak to company structure. I think you at Tesla had an experience where you were able to run at full speed. Maybe you could speak to the differing organizational structures or growth opportunities with varying startups and how important that is.
Oh yeah. So depending on your startup size, the scope of your role may change. I look at, for example, Tesla. Like there were times at Tesla when I was working more than the traditional work week, numbers of hours that may shock people. But there was nobody that was telling me that I need to work that much. It was sort of like, for somebody that's passionate, they give you opportunities. And you go to a traditional company and it's kind of like the army, it's like you're given a project, you're given a role, you stay in that, and that's it. If you do a good job, you're expected to do a good job. You will get rewarded in 5 years, you may get a promotion. But kind of like in the army, if you're a lieutenant, you can be a captain in 10 years. But I did a good job. We don't care. In 10 years, you can be a good captain or a bad captain, but it'll happen in 10 years. So, a lot of traditional, especially aerospace companies, are kind of like that, and they're very siloed. But, at Tesla, it's kind of like when there's a problem, they need, somebody or a few people on it. When that happens, you have the ball. When you have the ball, you run. And it's like all the doors start opening for you. People start to help you. You get resources. And you don't want to go home. You want to solve it. You want to kill it. And it's fun because, this if this is what you wanted to do, you're getting to do it, and you're getting to do it fast, and you're learning along the way. And you learn how to ask people for help when you need it, and you grow. You grow into the size of your tank, and you have a bigger tank there, if in the world where we're all fish.
Thank you for that analogy. I was searching for gas tank. Awesome. Well, hey, Jonathan, I want to be respectful of time. We are coming up here at 8 o'clock. I know you have another meeting, but thank you for hopping on for this podcast interview. I know everyone who's listening really benefited from your journey, right? Starting a company to what you're working on today, and your learning experiences, especially for folks who are in college and figuring out what their next step is. Get out there, do an internship, look for the right fit in terms of company and growth, and don't be afraid to run with the ball and wear multiple hats.
That's it. It was a pleasure to be here. Thank you, Marcus. This is
of course, Jonathan. Of course. Awesome. And before we close out the call, I always like to leave a section at the end. If you want to insert a plug, maybe if people can get in touch or want to follow you, where's the best place to do that?
I'd say LinkedIn is a good spot to find me. Jonathan Nutzati. That's
all right. And we look forward to big things to come in the future here for Mothership Aeronautics. Looking forward to seeing the carrier flying around one day.
Thank you, Marcus.